Okay, let's consider this scenario. Let's say United Soup Can Company makes soup cans. No surprise there. All of their cans have circular tops and bottoms with a radius of 25 centimeters. So you guys have all probably seen soup cans or other kind of cans before. You've probably noticed that the top and bottom of those cans are circular, right? Well, all of the cans that this company makes, those circular tops and bottoms have radiuses of 25 centimeters, but they make custom orders with whatever height a customer requests. So different cans have different volumes. Okay, so let's see. If we're talking about volume now, do we know the volume of a cylinder? Because that's what we're dealing with, right? A soup can is in the shape of a circular cylinder. So we hopefully know that the volume of a cylinder is equal to pi times the radius squared times the height, h. So can we simplify that formula to deal with the possible volumes that this company's soup cans can have? Well, let's get some space here. What do we know about this company's soup cans? We know that all the radiuses are equal to 25 centimeters, right? So therefore, we can simplify this formula a little bit, and we know that the volume of all these soup cans will always be pi times 25 squared times the height, right? And what is 25 squared? That's going to be 625. So we know that the formula for the volume of this company's soup cans is always going to be 625 times pi times h. All right, what if we were asked now to come up with a function that gives the volume of these cans depending on how tall or what value of height different customers want to order these cans for. So let's create some space here. So let's say we wanted a function that gives us the volume of these cans depending on the height that the customer wants. So that means we want a function for volume depending on height. It probably makes sense to write that as v of h, doesn't it? A function of volume depending on height, or a function of height which gives you volume, and v of h in this case is going to be equal to 625 times pi times h. All right, so let me try to create some space here. Let's create some space over here, and let's evaluate, let's attempt to evaluate this function for different inputs, okay? What if someone wanted a soup can with a height of, I don't know, 50 centimeters, all right? What if someone wanted a soup can with a height of 50 centimeters? Well, to find out the volume, we would take our function and plug in h equals 50, right? And we would evaluate 625 times pi times the value we've chosen for h, which in this case is 50. So let's try to evaluate this. And this is going to be a lot of volume. It's going to be about 98,175 cubic centimeters in this case. Okay? What if someone also wanted a very, very short soup can for some reason? What if someone wanted a soup can with a height of, let's say 7.5 centimeters? Well, we would calculate the value of the function v of 7.5, right? That would be 625 times pi times 7.5, right? And if we went ahead and evaluated that, we would get the resulting volume of 14,726 cubic centimeters. In both cases, I've rounded, of course, to avoid writing a bunch of decimals. we were given the function f of x equals 5 times x squared minus 2 times x. And let's say this was given with a restricted domain. So you might look at this formula and think, okay, 5x squared minus 2x, it looks like if I plug in any real number x, that's going to be allowed and we're going to be able to get an output. And you're right about that, but sometimes your domain will be restricted. In this case, we're being told that this is a restricted domain, and the domain of this function consists only of the numbers -1, 0, 1, 2, and 13. All right, so we were told the domain of this function, and now we are being asked, what is the range of this function? Well, let's remember what domain means, right? Domain, or the domain, is the collection of values that can be used as inputs for the function, right? And your range is the collection of values that are the outputs of the function. Okay, well, if we know what the domain is, we can use each of those values as inputs and then evaluate the function to find every output, right? So to find the range, we are going to need to evaluate f of -1 and get the result. Evaluate f of 0. We're going to evaluate f of 1. We are going to evaluate f of 2. And we're going to evaluate f of 13, right? All right, so let's get started on that. Let's try to evaluate f of -1, okay? F of -1, it's going to be equal to 5 times -1 squared, right, minus 2 times -1. All right, that's going to be equal to 5 times -1 squared is -1 times -1. So our first term is going to be 5 times 1, all right, minus, what is 2 times -1? 2 times -1 is -2, so this is going to be minus -2, right? Let's keep simplifying. 5 times 1 is 5. Minus -2, remember subtracting a negative is like addition. So minus -2 is like plus 2, and 5 plus 2 is 7. So we found one member of the range. Let's keep going. Let's evaluate for our second member of the domain. Let's evaluate f of 0 to find the next output, and therefore the next member of the range of this function. That's going to be 5 times 0 squared minus 2 times 0, right? Because remember, we have our formula. When we're choosing a value of the domain and plugging it in, we're just replacing everywhere we see the variable in the formula with that value. So 5 times 0 squared is 5 times 0 times 0, which is 0, right? So this first term becomes 0. Minus 2 times 0 is just 0, right? So look at that. F of 0 produces 0. So 0 is the next member of our range. Let's do one more together, and then you guys can try the other two. Let's try to evaluate f of 1. Let's try to evaluate f of 1, and let's plug that in for x. So wherever x appears in our original formula, we're going to replace it with the value 1. So this first term becomes 5 times 1 squared minus 2 times 1. Okay, our first term is 5 times 1 squared. 1 squared is 1, right? So this becomes 5 times 1 minus 2 times 1. That's just minus 2, right? 5 times 1 is 5, so this becomes 5 minus 2, which equals 3. All right, so we've already found 3 values of the range, right? So we know that our range is 7, 0, 3, and maybe 2 more, right? So why don't you guys, as your next question, go ahead and try to evaluate this function for the last 2 values of the domain, and why don't you try to find the rest of the range for us?